Welcome uh, to this lecture. So, actually, in the previous lecture, we talked about the separation of mixtures, and we studied the three type of the mixture. One is the mixture of solids, and second one is solid and liquids, and third one is the mixture of liquids. So, actually, we studied the different techniques by which you can use to separate all these three different type of the mixture. So this syllabus, actually the course contents are included in your theory class and as well as in your laboratory. So that's why I am combining all these class and the lab. So the content are included and will be included in both of your class and the lab as well. So before going to the next topic, so actually today we will finish the techniques. How can you separate the mixtures by using different techniques, and then I will show you with the some of the experiments, and we do some exercise over here to just to finalize and to decide what type of the techniques we are going to use to separate the mixture of solids, mixture of liquid and solid, and the mixture of the liquids. So let's first I'm going to show you a very brief videos clips. So listen and watch carefully about this video, and then we will be using the knowledge which you are going to the listen out of these videos, and then we will apply on our experiments and then decide what type of the appropriate techniques you are going to use to separate the mixtures. So let's I am going to share with you. So in this, the first one, actually you are going to separate the ammonium chloride by sublimation process. You know, in the previous lecture we studied the different techniques, and one of the technique is the sublimation, and the sublimation is the direct conversion from the solid to the gaseous phase. So the first have a look how this technique we are going to use to separate the ammonium chloride. Actually, ammonium chloride is going to be separated by the sublimation process. So just watch the video, and it is around 1.5 minutes, and then we will move to the next.
This experiment can be performed through the following steps. Separation of ammonium chloride.
So just any one of you can confirm either you may listen the audio of this video.
Yes, sir, we can listen the audio.
Okay, thank you. So just listen it carefully, and then we will move to the next exercise.
Chloride by sublimation. Take about 10 to 15 grams of the mixture containing common salt and ammonium chloride in a china dish. Place this china dish on a tripod stand and cover it with a perforated asbestos sheet. Place an inverted funnel on the perforated sheet. Plug the opening of the funnel with a cotton plug. Heat the china dish on a low flame. Let white fumes deposit as white solid on the inner wall of the funnel. After a few minutes, stop heating and allow it to cool. Remove the funnel and scrap the white deposit of ammonium chloride with the help of a spatula. Common salt and sand are left behind in a china dish.
So this was all about the sublimation process. You are just going to heat at the boiling or the melting point of the salt. So it will directly convert into the gaseous phase, and then when you dry it, you can collect the pure ammonium chloride by using the sublimation process. Now watch what is left behind and how we are going to separate the rest of the mixture.
Separation of common salt and sand. Transfer the leftover mixture containing common salt and sand to a beaker. Add about 20 ml of distilled water into the beaker and stir well with a glass rod. Take a clean glass funnel and place it on a funnel stand. Fold the filter paper twice and then make a filter paper cone. Set this filter paper cone in the funnel. Place a small beaker under the funnel. Transfer the contents of the beaker into the filter paper cone with the help of a glass rod. Collect the filtrate in the beaker placed under the funnel. Spray a little cold water on the sand in the filter paper cone. Collect this filtrate also in the same beaker. Remove the filter paper cone from the funnel, open it, and place the filter paper having sand on it in the sun. After some time, the sand gets dry. Collect it in a plastic pouch.
So this is just separation of sand out of the salt, and by just a very simple method that is called the filtration. The previous was the sublimation, and this is just the filtration. When your one of the material or the component of the mixture is solid and other one is the liquid, and you can easily separate the solid out of the liquid by using this simple filtration process. Now watch another one.
Recovery of common salt from the filtrate.
Now we are here, actually the salt is left, and salt is the homogeneous mixture of water and the salt. And now you are going to separate the salt out of the water. So let's have a look. It is a very simple technique to separate the salt from the filtrate.
Transfer the common salt solution into a china dish and heat it. When the water starts evaporating rapidly, lower the flame. Put off the burner when slightly wet residue is left. The white residue left behind in the china dish is solid common salt. Scrape the common salt with the help of a spatula and pack it in a plastic pouch. Result: all the three components, ammonium chloride, common salt, and sand, are separated by simple laboratory techniques. Precautions: during sublimation, flame should be kept low. During evaporation, heating should be stopped as soon as a slightly wet residue is obtained. Handle all hot apparatuses carefully.
So this in this video, actually you have learned three basic techniques. The first one is the sublimation, and second one is the filtration, and third one is the evaporation. So I am again going to show you another very short 1.5 minute video, and then after three video, I will be moving to our laboratory exercise, and then we will apply these technique to further study the.
Distillation is a method of obtaining pure liquid from a solution. In this process,
So this is the fourth one technique, and this is called the distillation. And actually, some of you have already performed this experiment in the lab. And after, hopefully in January, when you are back, we will perform again all these experiments. So just watch
the
this one.
solution is heated so that the liquid evaporates. Let's understand this with an experiment. Take some salt water in a retort and heat the retort till the steam comes out of it. We will see the steam getting collected inside the beaker in the form of droplets of water. The steam condenses and reaches the beaker, and the salt left behind in the retort. This method of separation of soluble solids from liquids is called distillation. Now, let's see how can we separate insoluble solids from liquids with an experiment.
So these techniques, in the same way as you have watched in the previous video, when we actually separated the salt out of the water by just evaporation, and this is the alternative to the evaporation. By using the distillation, you can do the same procedure, and you can also separate the water out of the salt by using the distillation. And distillation, as we talked about earlier, It is just the evaporation of the water, and then when it is going to pass through this condensation, it is further condensed and converted the steam to the liquid, and you can collect the water over here. So by evaporation you can also separate, and by distillation you can also separate. But what is the drawback in evaporation? In evaporation you are not going to collect the water, because the water is directly evaporated into the atmosphere. But here you can collect the both water and the salt separately by using the distillation. So next technique
To
is,
separate the mixture of sand and water by filtration,
this is
take a
the
round paper
sorry this is the same as has been explained before. So this is alternative to the what the distillation
and fold
process.
it to make a cone and place it over the flask. Pour water mixed with sand into the funnel. You will observe that clear water will get collected in the beaker, and the sand will remain on the filter paper. The pure water collected is called filtrate. This method of purifying water is called filtration.
So this is all about the filtration as explained before and in this video. Let's have a final look at this video, and then we will move to the exercise. And in this you will find a variety of the techniques to separate the mixture.
Separation of mixtures using different techniques. Separating funnel. To do this experiment, we require a separating funnel, stand with a clamp, mixture of oil and water, filter funnel, and beakers. Take a filter funnel and place it on the mouth of the separating funnel, which is clamped to a stand. Pour the mixture of oil and water into the separating funnel through the filter funnel. Oil and water will appear as separate layers. Remove the filter funnel from the separating funnel and close the separating funnel using a lid. Take the separating funnel from the stand. Invert the funnel and shake it gently, and slowly open the stopcock of the funnel to release the pressure inside the funnel. Place the separating funnel in the stand and allow the two liquids to separate completely. Oil forms the top layer and water forms the bottom layer. Take a beaker and place it below the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully onto the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. The immiscible liquids separate out in layers depending on their densities. The denser liquid will fall to the bottom, forming the lower layer, and the lighter liquid forms the top layer. Water is denser than oil. Simple distillation. We require a mixture of acetone and distilled water, stand with clamp, heating mantle, and porcelain chips. Take a mixture of acetone and distilled water and pour it into a 250 ml RB flask or distillation flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips using a spatula and put it in the RB flask to avoid bumping while boiling. Connect a distilling head to the RB flask and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask or receiver flask to the vacuum adapter. Take an ice bath and place the RB flask in the ice bath. Connect a rubber tube between the tap and the inlet of the condenser to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle to 56 degrees and heat the mixture to boil. At 56 degrees, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in a liquid form. Water is left behind in the distillation flask. Simple distillation is used for the separation of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Acetone boils at 56 degrees and water boils at 100 degrees. Fractional distillation. We require a mixture of methanol and ethanol, stand with a clamp, heating mantle, and porcelain chips. Take a mixture of methanol and ethanol and pour it into a 250 ml RB flask or distillation flask.
So this is a little bit the same. So I am going to skip this video because it's not, we don't have too much time. So moving to the next.
We require milk, distilled water, centrifugation.
So this one is another technique, and this is called the centrifugation. Actually, I have talked about all these techniques in the previous lecture, and it's better to understand by visualizing all these videos.
We require milk, distilled water, centrifuge tubes, centrifuge machine. Take a centrifuge and fill 3/4 of it with milk. Place the centrifuge tube in one of the holes of the rotor of the centrifuge tube. Take another centrifuge tube and fill 3/4 of it with distilled water. Place it opposite to the first centrifuge tube to balance the centrifuge machine. Then, close the centrifuge machine and centrifuge the milk for 2 minutes and stop the machine. Take the centrifuge tube containing milk from the machine and observe the changes. The fat rises to the top, resulting in a cream layer at the top and skim milk, that is plasma phase of milk, at the bottom. The denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Chromatography.
So this, I will be moving to this, the last technique later on. And now I'm going to show you the experiment and we will do some sort of the exercise. And this is very important because you will be attaching all these three different experiment in your lab manual. So these are compulsory for the lab experiment as well. So just have a look what is. So this is the our the experiment which you have some of you have already performed. So I'm not going to repeat all these experiments. Just we are going to decide over here what type of the separation techniques you may use to separate all these different type of the mixture, which have already been explained in the videos. So the first one is the salt and water, and the second one is the KMN4 and the water. KMN4 is the another compound. It is called the This is the potassium, this is manganese, and the whole molecule is called the potassium permanganate, and this is the water. So all these two are the homogeneous mixture, salt with water and the KMnO4 with the water. So remember what type of technique we will be using to separate the salt out of water. Any one of you can name what type of the technique can we use to separate the salt out of the water.
Vaporization, sir.
So very good. Shabash, vaporization. And other one, there is still another technique we can use to separate the salt out of the water. Which one?
Distillation.
Very good. Distillation and the evaporation are these two techniques we may use as explained in the videos to separate the salt from the water. And the filtration actually will evaporate the water, and what is left behind, it will be the salt. So you will only collect the salt. But by using the distillation, as explained over here, by using the distillation, it will be the mixture of salt and water, and when you evaporate, actually you can get the steam of the water over here, and then by using this condenser to cool down the temperature of the water, you will collect the water in the beaker. So in this distillation, you can get the both of the component present in the mixture. One is the salt, another one is the water. But by evaporation you can only separate the water because the sorry separate the salt, because the water is going to be evaporated and it is going to the atmosphere by using the simple evaporation technique. And in the similar way, this is also homogeneous mixture, and in the similar way you can use the distillation process over here. And when you boil the KMnO4 and the water mixture over here, and again water is evaporated, and after condensation you will get the water over here, and KMnO4 or the potassium permanganate will remain in the bottom. In the bottom, this is called the round bottom flask, and you can separate the mixture of the potassium permanganate and water by using the distillation. So these are the short questions. This file is has already been shared with you on Moodle in this week. So these are the three experiments I'm going to discuss over here. So first one is, did the temperature change significantly during the collection phase? Explain why or why not. So what do you think, any one of you? Is there is a change in temperature during the collection phase? Collection phase is over here. So when you collect the water, is there change in the temperature as
Yes,
compared
sir.
to, sure, how it is going to be changed?
Sir, due to the condenser, the temperature of the seam of the water decreases. That's why when it is collected in the beaker, the temperature of the distilled water is low. That's why the change occurs.
Excellent, very good. So because it is going to be evaporated when the temperature actually rises to 100 degrees Celsius, and when it is condensed, of course, the temperature would be less than 100. So there should be a significant the difference in the temperature between the collection phase and the evaporation phase. Very right. So why doesn't the salt disturb over with water? So why the water is going to distill, not the salt is going to distill by using the distillation apparatus.
Because salt boiling
Shabash,
temperature is very high.
Sir,
exact.
because
Shabash,
salt is solid.
the salt is solid and the water is liquid, and this may be the one of the reason the first liquid is going to evaporate and then solid, or you can say the correct reason of this one would be the because water is having the less temperature, boiling temperature as compared to the salt. So which one is having the less temperature? It will boil first, and then it will be the turning of the second one mixture. So that's why the salt is not to be going to distill over the water because of having the very high temperature as compared to the water. Very good. So these are the third one is the write down the chemical reaction between sodium chloride and this is sodium, this is chlorine, and compound is called the sodium chloride. This is the salt, common salt we are using, and this is the silver, and this the other one compound is the nitrate, and the whole molecule is called the silver nitrate. So actually this is the test. Actually when you collect the water out of the mixture of salt and water, if you get the pure water over here, that means pure water, it is not having the salt, that means it is not having the chloride in this solution. But this, in the round bottom flask, it is having the salt, that means it is having the chloride. And what is the test? We can confirm the whether you are collecting a pure water or it is having the contamination with the sodium chloride. So when you this is the again the salt what is in your round bottom flask. When you add few drops of the silver nitrate, you will get the white precipitate of the silver chloride. Your solution turns to turbid. That is the indication your solution is having the chloride ions in the solution. So if you are not having the turbid color, that means you are not having the sodium chloride, and that's why you are not getting the white precipitate which is formed with the reaction of the silver with the chloride. And this chemical is used to test the chloride. So यहाँ पे हमारे पास जो है, अगर आप इससे टेस्ट करेंगे तो इसमें आपके पास वाइट प्रेसिपिटेट आएंगे. इसमें से जो आप लिक्विड लेंगे और जब आप वाटर को टेस्ट करेंगे, you will not finding the white precipitate because it is a pure water. And it is again confirmation that by using the distillation you are going to separate the water out of the salt. So maybe I'm going a notification after 10 minutes this video will end up. If it is end up, you can join again by using the same link. So I'm going to the next question. Define distillation and how it helps in purification of this substance. So anyone of you can define what is now the distillation as you have seen, or what is I have explained in this lecture as well. Anyone? The distillation.
By boiling the mixture, we get the liquid out of it.
Okay, so it simply it is the two process. One is the evaporation. If we in chemistry terms we can use the terminology in chemistry. So we have already studied all these techniques. So actually the first step is the evaporation, as you can see over here. The first step is the evaporation, and then it is the condensation. So distillation is very simple. It is the evaporation followed by the condensation, that is called the distillation. Very simple to remember, and this is sufficient definition for you. And of course it is going to help because your liquid is going to evaporate at different temperature, and you can get the pure compound or the component of the mixture by using the distillation. This is just the, you can sketch the diagram as it is indicated over here. So moving to the next experiment, it is the this is the three components. The mixture is having the three component, that's why it is called the ternary mixture. Ternary mixture means it is having the three component present in the mixture. One is the naphthalene. So this is a molecule, just remember this is the organic molecule, this is the sand, and this is the table salt. So again, no, this is the combination of three mixtures. So just I'm expecting the response all of you. If any one of you can suggest what type of the technique we can use first to separate the any one of the component present in the mixture. शाबाश बताइए. You can name any one technique which you have, because we have you have already watched in the videos. So what type of technique you will be using? Shabash.
Sublimation,
Ex-
filtration, and evaporation.
Very good. Right. Sublimation and filtration, evaporation. Exactly. These are the three techniques. Actually, class participation is also required because I have fixed the 5% marks out of 100 in your class participation. And just don't be shy when you are answering. If it is not correct, I am going to correct one. So just your response is necessary. So I think you are engaged with me during this lecture. So, two of you have rightly said these are the three techniques we are going to use over here. One is the sublimation, other one is the filtration, and third one is the evaporation, as shown over here. So your first component is the naphthalene, and you can use the sublimation. Naphthalene directly convert from the solid to the gases, and then after this you can condense in this funnel as explained in the video, and later on you can collect the naphthalene by using the sublimation process, and you can separate the sand by using the simple filtration, and you can also use the separate the salt out of the water by using the evaporation. When you evaporate, water is going to evaporate and salt is left, and that means you are going to separate all these three components of the mixture by using three different simple techniques. So here it is very briefly, it is sketched over here. The first one is your mixture of naphthalene, sodium chloride, and the salt. This is the common salt and the salt. When you heat it at 250 degrees centigrade, so naphthalene sublimes, that means directly converted into the gases, and by using the funnel, inverted funnel, you can condense and then you can separate the naphthalene out of the mixture. So the rest mixture is left. This is the sodium chloride and the salt. And with the extraction of water, that means by using the filter paper, you can filter out the sand and the your NaCl solution. So this filter paper is going to separate these two components. One is the sand, and sand is left over the filter paper, and this filter paper is going to allow to pass this solution, and up to this process you have separated the naphthalene and the sand residue, and by because this may be wet, and when you evaporate the water you can get the sand, dry sand over here. And of course when you evaporate the water out of this NaCl solution by just evaporation, finally you will get the NaCl or the common salt. So these are the three basic techniques you are going to use to separate the ternary mixtures having the component of three mixture, and similar you can do with the more than one mixture as well. So these are the short questions over here. Do you see any difference between a homogeneous mixture and a solution? So any of can you explain the this is the mixture, and what would be the difference between a homogeneous mixture and the solution? So is there any difference as you suggest, or whatever would be your response? Any one of you, please. Yes, Abdul Wahab, Minail, are you there? I am calling the name, so please respond. Faz Elias.
Yes, sir.
So who is okay? This is Minahil.
Yes, sir.
So okay, thank you. So what do you, Minahil? Do you see any difference between the homogeneous mixture and the solution? Yes or no?
Mm, no, sir.
No difference. Very good. Because homogeneous mixture are actually called the solution. You will not see
Yes,
the
sir.
difference between the homogeneous mixture and the solution. This is the correct answer. So the next is the what is sublimation process. Give the list of the substance which show sublimation pattern. What is the reverse of the sublimation process? So sublimation is the And now I'm going to call another Mahvesh Arif.
Yes, sir.
So, what is the sublimation process? Shabash. So sublimation is the, because the video is ending in 1 minute, so I'm going to wind up this one, and after that you must log in again, and I will explain the last one, separation of the mixture. This is very important and interesting as well. So sublimation is you. I also encourage you to take the note, or maybe you can watch the video again. This video, sublimation is the direct conversion from solid to the gaseous phase, and the reverse of the sublimation is the from the gaseous to the solid. That is called the deposition. So these are the, you have to differentiate between the evaporation, sublimation, deposition, condensation, as explained maybe in one of the lectures. In the starting lecture we have discussed in detail what about the evaporation, sublimation, deposition, and the condensation. So I recommend to watch that video again. So I am ending this one and ask you to join me again.